So before I begin, just do let me know. Am I audible and visible to everybody? Please confirm me once. Am I audible and visible to all? Please tell me. Am I audible and visible to everybody? Tell me. And how's the energy? How's the energy? Are we good to go? Are we good to go? I'll just check in the comments. Are we good to go? Tell me. Then we'll begin. Right. Anyhow, today we are starting with hash map. So before I start the problem solving, I'll tell you what is the problem statement we are going to solve today, what is the hash map and why it is required actually. Okay, and then I'll begin with the problem statement and then we'll do the solution. All three languages in Java, C++, and Python. Cool, yeah. So I hope your energy is high for everybody, right? But with really good dreams in their eyes, that people are serious about their career, right? They're very serious. Only then this particular thing for you. So yeah, today we'll solve a problem to some the first problem of the lead code anyway. And again, this particular problem has been asked in Amazon, Adobe, Apple, Facebook, Microsoft, Uber, X, Spotify, Snapchat, Samsung, Salesforce, Quora, Qualcomm, PayPal, Oracle, Nvidia, LinkedIn, JP Morgan, Indeed, Google, Goldman Sachs, eBay, and Dropbox, and many more companies. So are these questions enough for interviews? Yes. Yes, Fatima. These questions are enough for the interviews. But only when you just do not understand the solution, you understand the pattern. That if I'm solving 150 questions here, okay, so here I'm at least telling you around 20 to 30 algorithms that you'll see. 20 to 30 algo and patterns and all the data structures. If you understand that algo, you're able to solve 4 to 5 problem statement on that particular algo, then definitely I can say one thing that you're completely ready for the interview. Okay, you will be able to crack that. Right, but only when you have good understanding of all the algorithm that I'm covering, all the questions that I'm covering, and you're participating, you're practicing the similar questions, also participating in the contest over multiple platforms. That is the one way which will lead you to successful. Okay, that is the only way. So yeah, what is hash map especially? So basically, in JavaScript we had hash map also, but object structure, right? So we had key and we had value. So whenever you want the data in terms of key value pair, we always use map. We always use map. So map in Java also, map in C++ also, map in Python also, right? So whenever you want that, there should be data in which format? In key value pair format. Key value pair format. So in that case, you use hash map, and basically this will help you to optimize your solution. Optimize your solution. Optimize your solution in most of the ways, and also will help you to build a lot of good algorithms like a time will come when you utilize them into the sliding window, you utilize them into the prefix sum, right, and other things as well, right? So you will have that thing, that crazy things. Cool, yeah. So now probably I guess you understand what is the hash map. Now we'll go to the problem statement, we'll see that, and then we'll solve it. Okay, we'll check out that and then we'll solve it. Cool, yeah. So now here, but my attendance is very poor, yeah. That is not appreciated, right? And I want interaction. I want interaction. I want to see that. I want to check that you are really enjoying the series or not. But anyway, very soon we are going to complete our first 50 days. Like today we are doing 48, tomorrow 49, then 50. Like very soon we are going to complete our 50 days. So that is one achievement. You can appreciate yourself, and I really appreciate everybody for their hard work. Cool, yeah. So now here we have the problem statement to sum. What basically this problem says, given an array of integers nums, cool, and an integer target, we have two things. One is the nums array, second thing is a target, cool. Return return the indices of two numbers such that they add up to the target. So what we have to do, we have to return the indices, means indexes of the two numbers. If we add both of numbers, that becomes the target. That becomes the target. That is the problem statement. You may assume that each input would have exactly one solution, and you may not use the same element twice. Cooler means only one solution is possible. So which means that there will be only two elements whose sum is equal to the target. Cooler, for example, look at this. You have this nums array and the target as 9. So we'll take the element 2, then the another element that is, मेरी आवाज धीरे आ रही है यार I don't know why is that, but probably because of mic or something. Is it so? Yeah, today actually in my studio there is another setting going on. So probably I'll use the mic right here in the collar. Now probably this will be fixed. And now tell me in the chat, am I properly audible and visible to everybody? Am I properly audible and visible to everybody? Tell me in the chats. So now here, if you add both the numbers, if you add both the number, that becomes the equals to the target, right? Equals to 9. Yes or no? So basically, that time you need to run the index in terms of what? In terms of an array. So look at this. We are returning the index of 2, that is 0, and index of 7, that is 1. So we need to find two elements whose sum will up to the target. And then we return the indexes of both the elements. We will return the indexes of both the elements. Cool here, makes sense? Now another example also, look at this. We have this thing, we have target as 6. So if you see this 2 and 4, if you add them, that becomes 6. And now the index of 2 is 1 and index of 4 is 2. Right, so we're returning in terms of an array. Cool. Now another thing what we have another nums array 3 comma 3 and target is 6. If you add both the elements, we will get this thing. So I hope now so far the problem statement is calculated to everybody, right? The problem statement is calculated to everybody. Now what I want is here how we can solve this particular problem. So probably I'll write here the nums array. So we have this let's suppose 2 comma 7 comma what was the example, 11 and 15, 11 and 15, and here we have target, right? So there is a possibility that both numbers can be available on any place, right? So there is a possibility, but I can't see the interaction here. I want to see the interaction. Okay, if you're understanding, just tell me that yes, you're understanding this thing. I'll also feel good, right? So clear. So here we will have the target. Now there is a two ways. One way is that I can take two loops. One loop will give you the one element. For example, this two element, and then I can check the sum of this two element with all the other elements. So basically, I will have one external loop that will take one by one element and will check all the rest of the elements. If we get the sum, we'll return that particular indexes, right? So probably, what I can do, I can check with the all. So I have taken 2, so I'll check 2 with 7, so I just received. So in the best case scenario, probably you'll get on the first place or on the last anywhere. And there's a possibility. What if you have, let's suppose this 7 is available at the end, you don't have this, you have this thing. Is this sorted array? I don't think so. No, this is not sorted array. So probably let's suppose 2 you have here and 11, then 15, then 7 at the end. So you have to iterate this whole array, right? You have to iterate this whole array, or there's a possibility you get like this 11, 15, 2 and 7. Then you have to check for 11 first in rest of the thing in the rest of the array, then for the 15 in the rest of the array, then for 2 in the rest of the array, then you'll get the output, right? So in that case, you're utilizing two loops, and in the worst case scenario, what will happen? External loop and internal loop. In the worst case scenario, you will have the time complexity of big of n square. But this is not optimized. This is not optimized. And that's where HASMA will help you by having a concept of complement. By having a concept of complement. How? So basically, what I will do, I have this array nums. I have this array nums 2, 7, 11, 15. I have right here. What I will do, I will create a map. Okay, I'll create a map. And basically, in this map, I'll store the complements. I'll store the complements. So basically, not complement, then even the directly value, anything I'll store. So here what I'll do is that I have this 2. Okay, I have this 2. So what I will do, I have the target also, I have the target also. So here the target was 9. I'll take a complement. I'll take a complement. A complement, what is a complement? The subtraction value. So 9 minus 2, what was the value I'm getting? So I received 7. I'll check. Is this 7 available in this map? The answer is no, because map is empty. So what you will do, you'll put this 2 with its index in the map. So if this is not the case, if this is not available, put in map. Put in map. So now tell me what you will have. Now tell me what you will have. You will have here in this particular map, you will have this thing, the value that is 2 and its index that is 0. Cool, yeah. Now you will have another element, the 7 you have. Again, you will take the complementary. So 9 minus 7 becomes 2. Check, is this 2 available in this hash map? Yes, this is available. So if this is available, which means what? Which means, tell me, because we have stored 2, right, already. So if you will get the sum of this 7 and 2, you will have 9. That's why we have stored the complementary. That's why we have stored the complementary. Because now if this subtraction is this, so can I write this 9 is equal to 2 plus 7, right? And 2 if it's already available, which means that was an element. And this 7 is the new upcoming element, yes or no? So these are the indexes. So what will be my output? If that is available in the map, I'll get the index of that particular element. So I'll access this with the help of this key. I will access this with the help of this key. So I'll access with the help of this 2. I will have 0 as a value. Why? Because 0 was the index of the 2. So here in array, I can put on the 0 index the value 0, whatever the index I have stored in the map. And again, the next value of the complementary, this the upcoming element, and that was 7, and the index of 7 was 1. So 0 comma 1 will be my output. And what will be the time complexity now? So you are just doing in a linear time complexity, because you're not iterating over this array multiple times, you're iterating only one time. You're iterating only one time. You're taking the complement. If the complement is available in the map, you'll access the index of it, and then the index of the current element will return your output. Otherwise, if the complementary is not available in the map, you'll put that particular element with its index. That is the simple algorithm. That is the simple algorithm. And I hope this makes sense to everybody. This makes sense to everybody. So now what I will do, I'll go to the our LeetCode, and there I'll write the solution in all the languages. First, I'll write in Java. If somebody needs a driver, then tell me. I'll give it to you. Okay. So here, what I need a hash map. And that will store the integer value. This is actually the syntax of the hash map. So that's how in Java you create a hash map, and I'll also tell you how you can create a map in Python or in C++. Okay, so new hash map. That's how you create hash map in Java, and we have this cool thing. Now what I will do here, I have this hash map. Then I need one iterator to iterate over my array. So I will have an iterator int I is equals to 0. I is less than nums dot length, because I want to iterate that array, and then I plus plus. Yes or no? Making sense to everybody? Tell me in the chat. So now here, what I will do, I will have the complementary, that is target minus the upcoming element, means nums I. So now, how do you check a particular element in the hash map? So yeah, I'll just suggest everybody just check out what are the hash map and what are the methods. So there are a lot of methods in the hash map. One method is contains key. Basically, that will tell you a particular key is available in the map or not. So basically, here what I will do, I will check map dot contains key. If what key? If this complementary is available in the map, in that time I receive my output. I found these two elements, because complementary will only available in the hash map. We have stored that particular element. Yes or no? So now here in this case I can return my output. So yeah, you have two ways. Either you create an external array, then you put the value on 0 and 1 index, or you directly return here. So I'll directly return because I want to tell you new syntax. That's my purpose. So that's how you return an array, right? I want to return Pandey array. This is how, and here I'll put the values. The first value that is stored in the map, right? So map dot get what? That complementary. So I have that complementary. Another value is the I, right? Because on the ith index I have the another value which complementary is available. Yes or no? Cool, yeah. Now if this is not a case, then what is the case? The case is possible that that particular complementary is not available in the map. Then I'll put that element into the map, by which in future I can check it. So map dot put what? That upcoming element, whatever the element we have, and the index of it. Yes or no? At the end, if we do not receive, anyhow you need a return type in Java. So that's why if you are not finding anything, you return an array with minus values. So -1 comma -1. This situation will never come, because there will be an exactly wrong solution. But anyhow, because of this return type, you have to write this. Okay, you have to write this array. You can write anything here, but you have to return an array, right? So yeah, this is the thing. I hope yeah, this is quite clear to everybody. If that is clear, give me a thumbs up. Yeah, I can't see the interaction. That is not good thing. Just feel like an offline class. Yeah, learn from here and build your amazing career. Right. So cool here. It's working fine. It's beating 98.83%. The time complexity we will have as linear because we are using only one loop, and the space complexity also you will have linear because you're utilizing an extra data structure that is the hash map. That is the hash map, right? So now I'll just convert the same code to the C++, and those who want dry run, I'll give it to you. If this is clear, right? Clear, I'll understand that the concept is clear to you. Tell me, because this problem is super important. There's a higher chance you'll see the same similar problem in your interview or exam anywhere. Okay, so I will have here unordered map. Unordered. Your spelling is correct or not? Unordered. Unordered underscore map. So this is the syntax in C++ to create a map. So here I will give a name as map. You don't have, because you have vector, so vector do not use length function, you have size method. And another thing is that in C++ you don't have key. Basically in C++ 17 version people were using, okay, glad to hear Code House and Fretha. Okay, so basically, in 2000, and when the version C++ 17 we didn't had contains method. So in C++ 20 version, we have contains method. Before that, we were using find method. But if we have a modern method, that's why we're using this contains method here. And that's how you not return, you do not return in C++, you just simply return the value. And you don't have to use this get method in C++. You use with the square bracket. Okay, you access the value with the help of square bracket in C++. And similar also, you don't put here, you don't have put method here, you will just directly put like you're assigning a value to an array in that same way, okay, by using the square brackets. And also you will not return like this here, and rest same code will be used here as well. So I hope this will work. I have written everything is correctly. Right. So this is the important thing I want to tell you, and also the logic, how you can utilize a complement. Okay, because in future that will help you a lot. Trust me. The time will come when algorithm will become more complex, and if you will not have a fundamental understanding, you will struggle there. Okay, beating 100% here in C++, and the time and space complexity again same as linear. Okay, big of fine because we're utilizing only one loop. Now I'll convert the same thing into the Python. Okay, I'll convert the same thing into the Python. So here we have this Python, but in Python, the thing is that you don't have anything to define. So here you will directly write map as a curly braces. Okay, so now here I just want a loop that can iterate over my this nums array. So I can write I in a range of what the nums array that I have, the nums array that I have. Yes or no? I'll do a colon sign here, and then I'll compute my complementary. I'll compute my complementary. Yes or no? And now how will you check for contents? You don't have to check for the contents directly here in the hash, like in Python. You will have here if comp in what in map. So that is a method directly to check somewhere. And now once you've done this, you need to return, but you will not use this curly braces in Python. Resting is same, but you will not use curly braces. You just use square bracket. That is syntax they have actually. Oh, else I'll use my colon here, and I'll remove these curly braces. And again this thing, I'll return this, and again you don't use the calligraphy, that is for the map, and here you use this. Well, so this is a complete code for the Python, and I hope that this is quite clear to everybody. And I've received also few clear, which means that the logic is quite clear to everybody. And I'm again repeating, this problem is super important, beating 100%. Same time and space complexity is linear because we are utilizing only single loop, right? And one extra data structure, that is map. Cooler. I hope that this makes sense to all. And what is important thing to remember here, that how you can utilize this complementary, and also this problem statement, because this problem is very important because of this already has been repeatedly asked in these companies. So there is a possibility that a lot of startup, a lot of smaller and bigger company will ask you. So you need to prepare it better. Okay, make it an important problem. Yeah, that's what I wanted to cover in this video. See you in the next live. Till then, take care and bye bye. Again, one important thing before I leave, I just want to tell you, few people are not getting the playlist. So just go to the YouTube. Okay, go to the YouTube and there search for the Prepin Star. search for the Prep Insta, and here if you go to the Prep Insta channel, yeah, here you will have the playlist. Into the playlist you will get this playlist. Okay, here you will get this playlist. You can access every topic, all the video that I have covered so far. Okay, you will have that access here. You will have that access here. Okay, then guys, I'll wrap. Till then, take care, bye bye, and watch every possible live video. Bye bye to all. Be consistent. Take care. अब स्माइल करके छोड़ना भाई. हाँ, टेक केयर टू ऑल.